You're looking for x, y, and z. A lot of people want to assume that this is split in half, this angle here, and that this is a 45-degree angle. But nowhere in the problem does it tell us that that was split in half, or can we assume that that is a 45-degree angle. So what I would do if I was first going to solve this problem is I would probably start off by solving for x. You don't have to go in that order, but that's where I would go, because I can easily find x by doing the Pythagorean theorem. So using Pythagorean theorem, I know that the leg squared, which is x, plus the other leg squared, which is 6, is going to give me the hypotenuse squared, which is 15. 6 squared is 36. 15 squared is 225. So in order to get x by itself, I want to subtract 36 from both sides. If I subtract 36 from 225, I'm going to get 189. Now, I don't want x squared, I just want x. So I'm going to take the square root of both sides. And so for the measure of x, I get the square root of 189. I'm just going to keep it as the square root of 189. That way I don't have a fraction or decimal or whatever. Okay, now I need to solve for y and z. In order to be able to solve for y, I need to know the measure of this angle. I can't really find the measure of this angle without first finding the measure of this angle down here. So I'm going to find this one down here by using SOHCAHTOA, or trigonometry. So I know the opposite and I know the hypotenuse, so I'm going to do sine of the angle that I'm looking for equals the opposite, which is 6, over the hypotenuse, which is 15. In order to find my x here, I'm going to use the inverse sine function. So I hit the second button on the calculator and then hit sine. It shows up as sine -1, and then you just type in 6 divided by 15. Okay, when I do that, what I get is, let me grab my calculator here. I get 23.57. Okay, so I know this angle is about 24 degrees. If the two of the angles together make a right angle, then I know this other one must be 90 minus 24, which is 66 degrees. Now I can use trigonometry to solve for my y. I know this angle, I know this side, and I can use that to solve for y. So I'm given the adjacent and the opposite, so I'm going to do tangent of my angle measure, which is 66, equals the side opposite over the adjacent side. In order to get y by itself, I'm going to multiply both sides by the square root of 189. The square root of 189 times tangent 66 gives me 30.87. So y equals 30.87. I'm just going to round that to 30.9. So my answer would be 30.9 for y, which now allows me to solve for z. Z is comprised of y and the 6 out here. So if I add the two together, 30.9 plus 6, I get 36.9 for z, 30.9 for y, and the square root of 189 for x, which is about 13.7.